Welcome to the Lauder Institute at the University of Pennsylvania. I'm Jules van Binsbergen, director of the Institute and a finance professor at the Wharton School.
And I'm Jonathan Berk, a finance professor at the Graduate School of Business at Stanford University. This is the All Else Equal podcast. Welcome back, everybody. Today, we're going to do something a little different in the AI space. Everybody's obviously talking about AI and everybody has their opinion. And we thought rather than just get AI experts, instead we should get an expert on the human brain, because then we could ask the question, how similar is AI to the human brain? And more importantly, if in fact AI isn't similar to the brain, how close are we to replacing the human brain? Which I think is one of the big first order questions in AI.
It's certainly a question that a lot of people are scared about. Everybody's wondering at what point will humans be replaced by machines? And if AI could achieve human brain-like capacity, would that make humans redundant?
Yeah, so, a few years ago, I read what I consider to be one of the best books on the human brain, written by Jeff Hawkins, called 1,000 Brains. That book starts out with an amazing, simple observation, which is that the brain can't be a CPU simply because neurons do not fire often enough to compute. And so starting with observation, Jeff Hawkins develops this theory of the brain, and it's pretty complex, but at its root, the theory is the brain is a predictive device. It learns from its environment, and based on that, predicts what's going to happen in the world, and only goes into CPU mode when that prediction doesn't actually occur. Okay, well, the great breakthrough, I would say, for AI was that instead of trying to solve problems CPU mode, all AI does is predict the next word. And this similarity led to this incredible breakthrough. The Turing test, which for those of you who don't know it is, Turing said the definition of an intelligent machine is when a human being interacts with the machine and doesn't know it's the machine. And that for a very long time was the gold standard in artificial intelligence. Today, it's a joke. Everybody accepts that you can interact with AI and it looks like a human being. And so that breakthrough came merely because we stopped trying to solve the problem and all we tried to do was predict the next word.
In that sense, the fact that AI started working this way and be a large predictive model, and the fact that the brain is one large predictive model makes it clear that there's similarities to the way that AI is organized today and the way that the human brain works. I also like this idea of insight into how the human brain works in the sense that for a long time, intelligence tests had memory-based parts to it as well, right? And people said, if you're very intelligent, that means that you also should have a very good memory. And I never quite understood what those two things had to do with each other, because somebody who could really do a CPU type activity in real time, how does that necessarily interact with how good your memory is? But now that we've discovered that essentially the human brain is a humongous memory machine that uses all of these memories to create these predictive models of the world and try to just predict the next thing, I think it becomes quite obvious that memory and intelligence are very tightly linked.
So then the question, I guess, is if AI at a very high level is a model of the brain, does this mean that ultimately AI will become the human brain or maybe better than the human brain?
And Jonathan, what I think Jeff, our guest today, who I think is a foremost neuroscientist, I think that he would say that he believes that the current AI is not nearly close to what the human brain is doing. And I think he's in fact working on a company that is trying to make the new AI even more like the human brain. So let's agree that the human brain and AI are both predictive models. I do think that in terms of architecture, there's still major differences between the way that the brain is built and current deep learning or AI models are built.
Yeah, it depends how much important you think architecture is, how much important you think the approach is. I don't necessarily share your view on that. I think the advances in AI that have come just from this predictive model have been so enormous that we obviously must be onto something. And if we're onto something, I actually think that we're going to see huge progress. Now, whether that means we'll replace human beings, I don't know about that. But I really think this could be an advance larger than the invention of the computer, larger than the internet, bigger than the telephone.
So, given the fact that in the interview itself, I don't think we're going to have that much time to talk specifically about what Jeff did in the book, Jeff Hawkins, and he wrote this book called 1,000 Brains. Maybe we should spend a little bit of time on what exactly his argument is about how the human brain works. It's also for our listeners to understand why it sounds in many ways like the way that AI is currently being implemented, but also maybe to get some senses of the differences. So it's called 1,000 Brains because essentially Jeff argues in his book that the brain is organized in cortical columns, and those cortical columns all develop models of the world that are of a very particular part of the world. So they're very specific models. And these columns combined are going to try to give you an integrated view of how the entire world works. And there's even a consensus sort of mechanism between these columns where you need to choose between which model is the most relevant in the current context. And it also allows you, due to the way that these models interact, to try to take different perspectives in which different models could be dominant for different parts of the argument. And so this consensus mechanism of very specific small prediction models of the world and then taking all of them together to combine them into one big human intelligence, that's quite an interesting and revolutionary view of the brain.
Yeah, Jules. I mean, obviously, the current AI models don't work like that. That's not really like basically current AI models do this massive regression. That said, the problem that is being solved is when the brain receives inputs, how does it decide what it's seeing, essentially? And the way that happens is, as you say, it goes down into these cortical columns and it says, look, is this input consistent with this event or this event? And obviously, since many events can have similar inputs, the brain's mechanism for deciding which event it is this voting mechanism. And obviously, we don't see that in AI. Having said that, there's the big picture. That's what AI is doing. It's taking the input and saying, okay, given this gigantic memory that AI has, what is it consistent with? And whatever it's consistent with, we know the next move. And so from my perspective, the big picture in that book is something worth thinking about, and I would highly recommend reading it. All right, I think at this point, Jules, maybe we should introduce our guest and let him speak for his own book, and rather than us who hardly know anything about the brain, talk about the book. So our guest today is Jeff Hawkins. He's probably best known amongst laymen for starting Palm Computing, which marketed the Palm Pilot. And for those of us who are old enough, remember that revolutionary device, particularly the language that was used to enter data, which Jeff invented, and he has some good stories about that in the book. After Palm was over, Jeff devoted his life to his real passion, which is how does the human brain work? Founded Redwood Neuroscience in 2002, and then co-founded Numenta, which is a research organization devoted to figuring out how the brain works. As we already mentioned, he's also author of 1,000 Brains, which I highly recommend, worth reading. Jeff, welcome to the show.
Thank you. It's great to be here.
It's great to have you, Jeff.
Well, Jeff, everybody talks about AI. The reason we were interested in talking to you is I've read your two books, one of which is 1,000 Brains. And, you start that book off with making an observation, which I thought was pretty important. And once you made that observation, it seemed to me that you were right in saying that the way most people approach the human brain was incorrect. The observation was that neurons just don't fire often enough to be a CPU, that they're too slow to be a CPU. And as a result, you have to rethink. Now, what I took away from that book was the way the brain works is this gigantic memory device that basically predicts the next move, and that the only time it goes into CPU mode is if the next move is unexpected. That seems to me AI. Tell me why I'm wrong or right.
There's a lot packed into that first few sentences there. So as opposed to me sort of kicking them apart, let me just take a fresh approach at it. The brain is not a computer. We can just state that emphatically. It doesn't work like a computer at all. It is a type of memory system. That doesn't help you too much if you want to understand it, but it's a big difference. And it doesn't look like a computer. It doesn't operate like a computer. Nothing is possible like a computer. And what it does is essentially it learns about the world, and it builds a model of the world. And you have in your head a model of the world. Everything you know is learned through observation, and you have this model in your head. And this is the essence of intelligence, is learning by interacting with the world, developing an internal model of the world, and then using that model to make decisions. That's what we all do. What we all do in our lives, in our personal lives, and our business lives. We have a model how we think the world works through observation, and we use that model to make decisions about, okay, if I want to have some outcome, how do I do this? How do I do that? It's nothing at all like a computer. We can just leave computers behind. It's zero like a computer. It's really this learning system. And my work has been primarily to understand how the brain does this in detail. How does it build these models? What do they look like? And how do they lead to decisions and our actions?
I know that the brain isn't a computer, but the big advance in AI was to stop trying to solve the problem and instead just predict the next word, just like the brain from the memory device.
Right. So in some sense, you could say today's AI is a prediction machine and brains are prediction machines.
Yes.
But that's true at one level. At other levels, other fundamental levels, they're very, very different. And these differences lead to both the why AI is powerful and what its limits are, and why it's really different than brains. Brains learn by interacting with the physical world. You touch things, you look at things, you hear things, you move your body through the world to see where things are. You touch things and you know where they are. So we have this interaction with the physical world. Today's AI systems don't do that at all. They interact with text or words or images streaming from some server someplace. They're not actually capturing the physical world. They have no essence of what's really out there. So this is why they can make all kinds of false assumptions. They don't know what the physical world is like. They don't interact with it. And the second one, which is equally as important, is how information is stored internally to these systems. In brains, everything is stored relative to locations, what we would call a reference frame. Knowledge is stored in like a coordinate system that lets you navigate knowledge and navigate the world. In these AI systems, they have nothing like that. It's just very linear. It's just like, here's a stream of bits, predict the next one. And so that can be very powerful in some situations, and I'm not trying to say they're not useful. I'm just saying that they work really differently and they have different results between, how real intelligence works and how these artificial systems work.
But Jeff, in terms of the training samples that you give to the AI, you essentially make it meet the physical world to the extent that you want it to meet the physical world. And you can do the same thing with humans, right? Humans have certain experiences, and if suppose that you're able to travel, then you can expand the amount of interactions you have with the physical world. Whereas if you choose to stay in your house, then you have a very limited thing that you train the models in your brain on. And so when we give AI all of the information that we wanted to learn from in the training samples, isn't that just how we let AI meet the parts of the physical world that we wanted to meet with?
I mean, you can't imagine what something feels like. It can talk, it can play words back of what someone else said something feels like, but it can't actually ever know what something feels like. So if it says, oh, cats are soft and fuzzy or furry, it doesn't know that. It's just saying that's what people have said. And so there's this disconnect between the physical world and the knowledge that they have. Again, this is not about dissing the current AI systems. It's just pointing out they work differently and they have limitations. So it can fool people because we communicate often via language. And so it's very good at imitating the language that we create. So that's very useful. But there's no innate knowledge about the world in it. And this is why they can make ridiculous assumptions sometimes. They can say things that's just not true.
For years, when we tried to get computers to be intelligent, what we did was we said, let's solve the problem. Let's let the CPU rationally solve the problem. And then we came around and we said, wait a minute, why don't we just predict the next word? And suddenly computers were much more intelligent. Admittedly, we can interact with the world differently to computers, but at the fundamental description of the brain as you understand it, it is that predictive device. So my question is, haven't we inadvertently in AI discovered the process by which the brain works?
Absolutely not.
Yeah, okay.
Now, yes, at some level, I can say brains make predictions and AI systems make predictions. It's fine. I'll agree to that. But they're completely different under the covers. They lead to different results, different problems, different opportunities. There are limits to what you can do with today's AI that are not going to be overcome.
So that's where I want to go. Given your understanding of the brain and your understanding of AI, what is the future? Is the future chess, where no human being can beat a computer program and ever will be able to beat a program in chess? Or are there limits that the human brain will always be better than AI?
No one knows the future, right? No one can predict the future completely. And I can't, you can't. Well, I can't speak for you, but I can predict for your sake and myself. But I can see limits to what can happen. And I can also see analogies to what can happen. So we have today, in today's AI, a technology that's quite useful. People are still discovering what it's good for and what it's not good for. There'll be a lot of experimentation. Many of those experiments will not turn out well. Some will turn out well. And so this is a technology that's going to be around for a while. You know, we have a lot of technologies like that, all kind of communication technologies, calculators, computers, whatever. But they're not intelligent systems. And so it's the nomenclature problem here, really. I mean, I don't say my calculator's intelligent. It does math faster than I do and more accurately. But I don't say it's an AI system, but you could. So what I can tell you is that there's another technology that's being developed, lots of people working on it, including myself and others, that learns and makes predictions using a very different methodology. And that methodology will turn out, I predict, that technology will turn out to be the dominant AI technology but some number of years in the future. I don't want to take exactly how many years, but we understand it. We're building it now. And so people will discover the limits of today's AI. They'll discover its strengths and weaknesses, but there will be another AI technology works on different principles that also makes predictions, but that's not what it's trying to do. It's trying to manipulate the world. By the way, in the end, we don't want an AI system just to make predictions. We want to impact the world. We want to have things that make decisions, interact with the world, and accomplish things. You know, that's what real biological intelligence systems do. It's not like one or the other.
So can you elaborate a little bit more about how different the one system is versus the other? What are the key basic premises that you're going to change? So do I understand correctly that you want the newer AI that will become dominant to be more like the human brain, or just different, or less like the human brain?
Well, it will be like the human brain because that's how it's being developed. So I'm a neuroscientist and a computer scientist, and I spent 25 years really in full time deciphering how parts of your brain work. And we understand it well. And now we understand and go, oh, that's what it is. That's what intelligence is. I get it. It's not like I just need to copy a bunch of neurons. It's like I had to figure out what they were doing. And now that I know what they're doing, we can build systems that work on the same principles. And those principles are different than what we have today. So there's a lot of things. I mean, on the surface, there's some easy ones to pick apart. Humans learn with very little data. We don't have to see millions of examples or hundreds of millions of examples to do something. I can give you a problem, a new thing to look at. You look at it for a few seconds or minutes, and you're up and running. There's nothing like that in AI today. They have to be trained on massive data sets. They are particularly power hungry. Everyone knows they're building these mega trillion watt power plants, whatever. But brains work incredibly, 20 watts, the whole thing, right? That's not just because it's neurons. It's the way the whole system works. Brains also don't make the kind of mistakes that AI makes today. They'll never confuse the bus for a banana. Those things happen in AI today. There's a whole series of little things like that. But at a fundamental level, it's more important. At a fundamental, it's how information is learned and how it's represented inside your brain, inside these systems, which leads to the ability to make decisions about novel situations and about modeling the future, which AI systems really aren't very good at.
I really like what you just said for the following reason with the current AI. One thing that I always said in class was that in the end, the price of energy is going to be one of the most scarce resources. So if the brain is super efficient and all I have to do is give you an apple and you can solve tons of problems, and the AI that we currently have takes these massive amounts of energy, that alone could be a competitive disadvantage for AI that is debilitating. But what you're saying is you're developing an AI system that might actually be just as energy efficient as the brain is. Do I understand that correctly?
Yes, but that's not the goal. That's an outcome. Right? We didn't sit around and go, oh, let's make this more energy efficient. We built a system that works on the principles of brains, and that is more energy efficient. It's the way information is processed and how you learn it makes it more energy efficient. Again, if I only have to have 20 samples of something to learn a model of it versus 20 million, you're going to be more energy efficient. That's clearly one of the advantages there. So it's a complex field. This is all evolving. If I were to think from a business person's point of view, I would say, hey, this is so new. we have to be careful. We have to go slowly, do your tests and figure out what works for you and what doesn't work for you. But don't be fooled into thinking today's AI is going to, take over the world and replace everybody. It's just not going to happen. And it's going to be just another technology under our belt. And there'll be other ones like the ones we're building, which are actually much more intelligent and more capable.
Jeff, it has shocked me to see creativity and intelligence emerge from AI. I wrote a song in 10 minutes on AI from beginning to end, fully produced. And when I play it for people, they go, my God, it sounds like Taylor Swift. So that has really, really shocked me to the core. And the question to me is, what does that say about what intelligence is in human beings? In other words, there's cross-sectional variation in people's ability to create songs themselves. What determines that cross-sectional variation, and what does AI have that, I couldn't create that song myself, put it this way, that I don't have?
Let's talk about what AI has. It has access to hundreds of thousands or millions of songs and can internally process them and store them. You can't do that. Your brain's not that big. It doesn't, you can't experience all that stuff. That's one of the things it has. And so it can build a sort of agglomeration of all that previous knowledge, which humans can't do. We have to filter more and selectively pick what we think is important. Most people can't write songs because that's not what they do for a living. They do something else for a living. Most people can't teach business school classes like you guys can because they don't do that for a living. And so we have to pick and choose what we are going to become experts on. So I wouldn't be fooled by that. I mean, yeah, should we be surprised that if I gave a system every song ever written, that it might be able to produce some songs that will sound like songs we've heard before? Yeah. Would it come up with an entirely new genre? What if Bob Dylan never existed? Would it come up with a Bob Dylan type of genre, whether you want that or not? Probably unlikely. It's because it's playing back things already, things that other people have done. It's basically gathering up world's digital media and spitting it back at you. So we shouldn't be surprised if it's good because...
And Jeff, what was the advantage Bob Dylan had in his brain that then come up with the new genre?
That's impossible to say, but I can say this. We all have different experiences, right? And because we have different experiences, nobody lives the same life. We end up with different models of the world, different understandings. This is not true of today's AI. ChatGPT is the same for everybody. Everybody gets the same thing, right? If there's one corpus of learning that goes into a particular large model, and that's shared among everyone. We aren't like that. We all have different experiences. We've gone different places in the world. We've heard different people speak. People who have heard this podcast will have different experiences than people who haven't heard this podcast. And so we end up with these different models, and that makes us diverse. Maybe Bob Dylan was exposed to something early on in life that you and I weren't, that made him think differently about music. I don't know.
So, Jeff, if you're working on AI systems that are more like the brain, do you think that there's a big future for hybrid models? In other words, if you're saying one thing that Jonathan's brain can't do is store 100,000 songs, do you think that soon we will have technology that will just allow your brain to access an external set of memories that you can just pull in or load into your brain so that we compensate the human brain for the same thing? Do you think that it's in our near future, or is that really difficult?
So this is like the Neuralink type of thing, maybe, where you have the brain probes, things are going into, not through your ears and eyes, but directly into it. I don't think that's going to happen in the near future. I wrote about this a little bit in my last book, but there are two problems there. One is there's the biological problems, which are daunting, really incredibly daunting. Brains don't want to have probes sticking in them. And also that the level of detail in which neurons work inside your brain, you can't read them out. There's this huge impedance mismatch between how information is represented in the brain and how we might get it out of the brain. And the short answer is, I don't think that's going to happen. There will be examples, and already examples, of people who are able to say, who are paralyzed, who have some sort of neural problem, where they can regain some movement. And that's definitely possible, and it's happening. But the idea that you and I could, you could be sharing thoughts real time with a computer and extracting information from it, like as a stream of thought. You never say never, but there's a good chance that it'll never happen. It's certainly not going to happen in the near future, okay? But there's confusion because there's companies like Neuralink who say, oh, we're controlling this arm with this thing. Well, that's different. It's not the same as, thinking along with this machine.
So, Jeff, what do you think is the most likely future for the world with AI? In other words, are we going to be in a position where there will be, appreciable number of tasks that we do today that human beings will no longer do? And I guess another way of asking this question is, if I compare the invention of AI to the invention of the computer or the internet or the telephone, how big is it in these big advances?
Computers are a great example because, even though the computers were sort of invented in the 1940s, they didn't become super big until, several decades later. But they've also infused throughout life and everything we do, right? Computers are everywhere. No one could have predicted that. No one could have predicted how the computers would play out. No one predicted back in the 1950s that you and I would be talking on a screen here, through the internet. This is science fiction. But it had a big impact. I think AI in general have a similar impact on society. It'll take decades to play out. There'll be a lot of early excitement. Some of it will fail. It's not going to go away. It has very large impacts. I don't subscribe to this idea it's going to replace everybody. It's just like computers didn't replace everybody. Yes, there are jobs that no longer happen because people are using computers. There's plenty of them. But no one sits around and go, wow, all the jobs are gone. We got computers. Everybody's sitting around doing nothing. That didn't happen. And it's not going to happen here too. So yeah, there will be some notable examples of jobs that are replaced and people are going to make a big deal out of it. But mostly AI systems will be tools that humans will use to do the things they've always done, and they'll do them better. That's true whether it's today's AI or the type of AI that I'm working on. They're not going to replace humans, but they'll supplement us and do things that we can't do or don't want to do. But this dystopian view of the future, like AI does all the jobs and we don't need anybody, I just don't think that's true.
I'm sure our listeners are comforted by that statement, Jeff. I think a lot of people are comforted by that statement, and I hope you're right.
It's just going to be a tool, and if you didn't use computers today, there'd be a limited number of job opportunities for you.
Let me ask this question slightly differently, which is, modern technology did change the skill set that people needed to excel in society, right? For example, before machines, muscle power was an important skill set. Today, it's irrelevant, right? When you look at AI, do you look at particular skill sets that will become more or less valuable? Because, when I look at it and I think to myself, well, obviously the skill set to write a program is less useful. But what about the skill set to create something that has never been created? That might become more useful given the competition. If everybody's using AI, the only thing you have now is new stuff that isn't in AI. So that might become more useful.
Let's put it into business terms, okay? So let's think about an executive, C-suite type of thing, right? Some of those jobs are very rule-driven or have more components of rules and regulations, maybe the CFO or maybe, compliance officer of some sort, right? And AI can really help them it'll help them do a lot of the job and it'll change their skill sets. If you're a CEO of a startup company, by definition, you're doing things that aren't the rules. You're breaking the rules. That's the whole point, right? And so no AI is going to do that. I don't think an AI is going to come along, hey, I got this idea for a new thing. No one's thinking about this, a new business model. I just think it's going to happen. You take a classic example of like FedEx, they had this brilliant insight about, how to use planes and make transportation goods overnight. I don't think an AI would have come up with that, right? Because no one else talking about it. AIs can't talk about things that no one else talked about. It's out of the rules. So anyway, so the answer to your question is that some jobs will have more impact than others, but it just shifts things, as you point out. It shifts where people spend their time. I mean, by the way, I'll contradict what you said earlier. People still use their muscle power. I have people working outside my house right now doing some labor, fixing some things. And you and I also manipulate things physically. We still have to do physical things. So that didn't go away. What things we did, how much time people spent on hard manual labor and how much they spent on sort of more other types of labor, which has changed. So the same kind of things will happen here. The life will go on. People aren't going to be lost in the woods. Some people will take advantage of technology. Some people will be more impact than others. So it's an exciting time, but I think we can get ahead of ourselves, and many people are.
So, Jeff, let me just go down this one thing with you, because I don't think anybody has thought more about this than you. What is human intelligence? Why do some people make more money than others because they're more intelligent?
All right. So those are two separate questions. What is intelligence, and why do some people make more money than others? You don't have to be very intelligent to make more money than others. You could be ruthless. They're not.
Well, okay. That's a separate question. I'm an economist. I believe there's a relationship. Just first question. Why are some people more intelligent?
Well, all right. Intelligence is the ability to learn a model of the world by interacting with it. And we judge people's intelligence by how deep and broad or aspects of that knowledge, of that model. We might say someone's intelligent in a particular field because they have a very detailed model of that particular field, but they know nothing about art or something else. So there isn't one intelligence, right? We all learn something about the world. And what we value is when someone has deeper knowledge about a field than anyone else. We all have all different experiences. We have all different interests. And so you can be an intelligent artist, an intelligent musician, intelligent business person, scientist, it doesn't matter. And it's really just the quality of your knowledge about that space and the kind of model you created internally in your head. The brain is a very complex organ. And when I study it, I study mostly the thing called the neocortex, which is the big wrinkly thing on top. Even in that organ, there's a lot of variation. It's divided into these regions. Different people have more stuff allocated to one region than another. They can change over your lifetime based on experiences. That is how the material in your brain is allocated, gets changed. It's not fixed. And of course, you could have someone who was born with some sort of deficit or disease or had some lack of oxygen or something, so the brain doesn't fully develop. All kinds of things can happen to make our brains different. There's no limit to the differences, okay?
The part that's really blown my mind is how creative the AI is.
Yeah, I mean, it is, I guess there's another way of looking at that. Perhaps you shouldn't be that blown away by it.
And why?
Just because you and I find something hard to do doesn't mean it is actually fundamentally hard to do. It's like, are you blown away that a calculator can calculate so rapidly and quickly? Well, why not? Because it's hard for our brains to do that kind of calculation, but it's not hard in some absolute sense. You know, when computers first started doing math like that, people were blown away by that. They couldn't believe it. They used to have teams of people trying to do mathematics. And now all of a sudden, so they just thought, this is amazing. How could this happen? And now we just think nothing of it. I think we're going to have the same kind of shift about some of these things that we find pretty amazing right now. In the end, we're going to realize that it wasn't that amazing. It just that humans weren't very good at it. And you call it creative, but I'm not sure I would go that far to say creative. I think you may be conflating the word creative with this stuff that you and I might find difficult to do. But computers have always been good at things that we find hard to do. They've always been better at finding data. They've been better at searching through things. They're better at communications, reliable transmission. I mean, all these things. So it's not surprising that computers can be, good at writing music too. And just because we have thought that, that's really hard because our brains aren't very good at that, doesn't mean that it's fundamentally hard. All right, but we'll see. The world's not coming to an end. It's pretty exciting. So,
Jeff, this was amazing. I learned a lot. I feel much better actually now. We had other people talk about AI before. They give much gloomier forecasts of what the future of humanity looks like. But I think you put a lot of things in perspective that were just very useful.
Great.
Thank you very much, Jeff, for coming. That was really interesting.
Thank you for having me. It was a great conversation.
Thanks for listening to All Else Equal podcast. Please leave us a review at Apple Podcasts. We love to hear from our listeners. And be sure to catch our next episode by subscribing or following the show wherever you listen to your podcasts. For more information and episodes, visit allelseequalpodcast.com or follow us on LinkedIn. The All Else Equal podcast is a joint production of the Lauder Institute at the University of Pennsylvania and the Graduate School of Business at Stanford University and is produced by University FM.